Okay, we're going to take a look at question number 43. This question asks you to factor. It also gives you information that you may not be given in your next course. It tells you to factor by grouping. One of the things that I want you to remember when you're factoring an expression, the first thing you should always look for is your greatest common factor and remove that first. The second thing, after you've taken out the greatest common factor, is you start looking for different patterns to help you decide how to factor what's left. So let's bring my camera down to my paper, and here we go. Let's get it in focus for you. There we are. So here's question number 43. Factor by grouping. When you look at the four terms, the greatest common factor that you could take out of all four terms is a 1. So in general, that's not very helpful. Even though the directions said to factor by grouping, you should have kind of known that factoring by grouping was going to be needed here for this reason. Whenever an expression is made up of four terms, factoring by grouping eventually comes to mind. So, let's hope they put it in the correct order for us. Let's group the first two, and let's group the back two. When I look at the first two terms and I try to find the greatest common factor of those first two terms, the largest number that I could take out would be a 3, and the highest power of x that I could take out of these first two terms would be a 2. So I'm going to pull out a 3x squared in parens, leaving me with a 2x minus 5. Now, when I look at the next grouping, we have the opposite of 4x plus 10. What we're going to do here, the largest number that pulls out of here would be a 2, and because this is a minus sign, it's in our best interest to take negative 2 as the GCF. So when I pull out a negative 2 in parens, I'm going to have 2x minus 5. Now, one of the things I want you to pay attention to, notice negative 2 times 2x gave me negative 4x. Negative 2 times negative 5 is the way I get a positive 10. So make sure that when you pull out that negative 2, you basically reverse both of these signs, not just the front sign but the back sign as well. Now, at this point, a lot of times students think, they're finished. You're not done. This minus sign right here indicates that this is a subtraction problem, not a multiplication problem. So you basically have one term here, and you basically have another term here. When you look at the two terms, what you notice is that 2x minus 5 is common to both terms. So that means that the greatest common factor of term 1 and term 2 is 2x minus 5. So we're going to pull that GCF out in front. That's my greatest common factor. I'm going to pull it out in front one time. In parens, what I would be left over with would be a 3x squared from the front, and then, and then a negative 2 from the back. Now, a lot of times my students ask me if the 2x minus 5 has to go in front or if it can go in back. It doesn't matter where it goes because it's a multiplication problem, and remember that multiplication is commutative, meaning you can multiply in any order and still get the same answer. But what is mandatory here, the 2x minus 5 has to go in parens, and the 3x squared minus 2 has to go in parens. It's an all or nothing factor, and it's very important you have the parens. So, there is my answer. Obviously, you do not have to write GCF. I just put that for emphasis. So, your final answer to this problem in factored form would be 2x minus 5 quantity, and then also the quantity 3x squared minus 2. Just for your further information, this factor would be called linear because it's degree 1, and this factor would be called quadratic because its degree is 2. So we have one linear factor and we have one quadratic factor.